Hi friends, this is Priyanka. In this tutorial, I am going to discuss the concept of queue in data structure. First, we discuss what is meant by queue. Queue is a special kind of list where we can store the elements or from which we can remove the elements. As you can see, the image of queue where the elements or the items are inserted at one end called as rear or tail of the queue and deleted from the another end called as front or head of the queue. This feature makes it FIFO data structure. The FIFO stands for first in, first out. This is an array representation of queue. If we want to create an array, we require number of entities. Consider as array, which is used for holding the array elements. Number of variables, which are used for holding the index of the front and rear element of an queue. This is the data type for queue. What we can do is we can first create an array of integer. I have created an array of 6 integer. We assign the value of index from 0 to 5. I have named this array, that is data. Now what I am going to do is I am going to use this array to store the value. The max is equal to 6 means the size of array. In this array I am showing front of the queue towards the left and rear towards the right. Does not really matter, any side can be used as a front or any side can be rear. It's just that an elements must always be added from rear and must always be removed from front. This is an operation on queue. First is initialize operation, which is used for initializing the queue, and we can assign -1 to front and rear. That means it represents the queue is initially empty. The next operation is enqueue. With the help of this operation, we can insert an element at the rear end of the queue. Next function is dequeue, which is used for delete an front element and return the same. The next function is empty, which is used for check the queue is empty or not. If the queue function empty is returns the true value, that means queue is empty. If it returns the false, that means it is not empty. Next function is full. The full function, which is used for check the queue is full or not. If the function full returns the true value, that means the queue is full. If it returns the false, then the queue is not full. We use the term queue in our day-to-day life. For example, we see a queue at airline or railway reservation counter or movie theater tickets counter. Before getting the service, one has to wait in queue. After receiving the service, one leave the queue. That means service provided at one end called front and people join another end called rear for getting the service. Here we consider the example of airline reservation system. First we initialize the queue. Here the front and rear initialize with -1 because initially queue is empty. No element can be inserted in a queue. If the customer A wants getting the service from the counter, then the customer A inserted into the queue with the help of rear. The position of the front and rear become 0 because the value or the element are inserted at position number 0. Next is we can insert a 3 successive customer, that is B, C and D. Front is equal to 0 and rear become 3 because we can insert element with the help of rear side. Therefore, rear is incremented by counter. It will become 3. The queue will look like this. After inserting element, we can remove the element from the queue. Then we can remove the front customer from the queue, that is A. The front become 1 because we can remove the element from the queue which is present at position 0. The queue will look like this. After removing A, we can remove 2 successive customer, that is B and C. Then the position of front become 3 and rear become same, that is 3. In this case, the front and rear value is similar. That means the particular queue contains only one value. After deletion, we can insert 2 new elements, that is E and F. The front will remain same, that is 3, and rear become 5 because we can insert 2 new elements. The counter of rear is incremented by 2. After inserting the element, according to the size of queue, we cannot insert new element. That means we cannot utilize this free space. A queue after 3 successive deletion of customer, that is DEF. The front and rear become -1. That means we can delete all the 3 elements and queue will become empty. The following points are observed. The queue is empty, then front and rear is equal to -1. Next, if queue is full, then rear is equal to max minus 1. The value of max is 6 minus 1 is equal to 5. The last position of rear become 5. If rear is equal to front, then queue contains just one element. If rear greater than front, then queue not equal to empty. The problem with the above representation of queue, if the figure 6 represent the queue become full, there are 3 vacant space, that is 0, 1, 2. We cannot utilize this space. If we move an element towards the left of vacant space, the process will consume the more time. The solution for that, we require the linked array. With the help of linked array, we can easily utilize the space properly. I hope you understood the concept of queue. Thank you friends to watching this video.